Let's do a little bit of energy math, shall we? So here we're looking at electricity calculations, and for part A, we want to know how many kilowatt hours are used per day. So I always like to write my ending units at the beginning, so I know what I have to have in the numerator and what I have to have in the denominator. And then I can figure out which pieces of information I have that will let me get there. So for example, I need kilowatt hours and I've got watts, so I need to have 200 watts converted into 1 kilowatt is the same as 1,000 watts. Now I know I can get rid of those units and be left with one of the pieces I need, but I also need hours. So now I'm going to multiply across by the number of hours. So that's 9 hours that are being used for every day. So now I've got my kilowatts hours per day. And so that will give me my 1.8 kilowatt hours per day for part A. And then for part B, I want to do the same stuff, but I am switching out what kind of bulbs I have. So there are two 9-watt bulbs, so that is 2 times 9 is 18 watts. All staying on for 9 hours. That's a much smaller number, 0.16 kilowatt hours per day. And going back to part B, how many kilowatt hours are saved? So I have to be careful that I am putting that in a math problem that says, if I used to have this and now I'm spending this, I am saving 1.64 kilowatt hours per day. And there's my answer to part B. Part C wants me to turn it into money. How much money is saved per year? Dollars. Okay, so I want to know about dollars per year, and I'm going to be working with this thing here. So 0.22 dollars per kilowatt hour. I've got the dollars, but I got to get rid of these kilowatt hours. 1.64 kilowatt hours per day, which is great. But now I still have a unit I don't want. So let's get rid of that as well. And if I get rid of that with the number of days in a year, assuming that's on all year, then I am left with my units that I want, and I can simply solve for that and get 131.69 saved per year, which is pretty good. There's a reason why we want to get rid of these old inefficient bulbs and replace them with the newer ones. We have learned how to do efficiency calculations, and so let's take a look at that real quick too. Percent efficient, sometimes you're solving for that number, but you could also solve for one of the other parts, as we're going to do here, right? Remember, in these kinds of efficiency calculations, you have to make sure you have the same units in the outputs and inputs. So we are looking at an output of 110 BTUs per day, and we want to know what the input was. And we have the efficiency. So 94% efficient. Our output is 110 BTUs. We want to know how many BTUs it would take to do that. Right, here's a question mark. And we should realize that because the efficiency is less than 100%, that this number on the bottom is going to have to be bigger than the number we started with. So if we reorganize all of this stuff to put our how many BTUs over on the side, then that will let us reorganize everything so that it is 110 BTUs divided by 0.94. There's our efficiency. As something to notice, when you are dividing by a number that is less than 1, then your result will end up greater. So 117 BTUs, and that's how much is coming, we have to put in order to get our heat to come out like that. So that's per day. And if we want to know about per year, then we're going to run this heater, not every single day of the year, but 130 days each year. So 130, well, let's just erase that. Let's just redo it all. Times 130 days per year, which will let us calculate that out to, if that was 117 BTUs per day, we're actually going to be using 15,210 BTUs per year. And then we could find out how much it costs.